Okay, so today we're going to be working through an example of factoring a quadratic trinomial where a, which is 4, is not equal to 1, and I'm going to be demonstrating this using the block method, which is a really good way to see visually what is happening when you're factoring trinomials. So remember that this 4 is a, 12 is b, and 5 is c. And the blocks we have here, the x squared blocks, represent there are 4 of them because they represent x squared, and there's 4x squareds. And then the 12 here is for these skinny rectangle blocks, which are the x blocks, and also known as b. And then 5 over here is the 1 blocks, so we have 5 of those. So this is kind of just a guess and check, and you're reordering these blocks to see which combination, or it's like sort of like a puzzle. You're trying to fit the pieces together. You use all of these pieces to try to make a perfect square or rectangle. So that means a rectangle that's not missing pieces, that's just full and complete, like the squares over here. So when working with these, it's always good to start with your x squared blocks and your 1 blocks. This is because these blocks in here, this is what you're filling in. So these, especially when you're dealing with negatives, are kind of subject to change. And how these blocks are positioned, we know A and C always stay the same. And how they're positioned affects how many x blocks you have in there. And we need 12. So we're just going to start with using these blocks. I'm just going to leave these x squareds how they are in the square shape, because when I have 4 I like to start with a square, but they could very well be like this. I mean, like that. With this one over here. We don't know that yet, so we're just going to start with this because it could change. And then I'm going to grab my 1 blocks and bring those over here too. Now we could try having them like this, stacked on each other, but I don't think that's going to work because we have an odd number of blocks. So I'm just going to lay them next to each other, like this. Okay, so now we have these in a position. Now this could change, but we're going to just try this. So first we have to fill in this space over here. So I'm going to grab 2 x blocks. So you see what I'm doing? I'm trying to fill in the space, and I'm trying to see the dimensions, how many we need on each side to make this rectangle or this square complete. And that'll show us what factors. I don't think I have these blocks as the right size. Sorry. I'll make it a little bigger. That. Okay, so those fit in pretty well. Now we're going to have to bring the rest of these over here. Let's see, just filling these in. It's a little tricky to do on the computer. Okay, it's looking pretty good. Okay, I'm just going to grab this whole chunk over here and fill it in. Okay, so you see my lining them up isn't perfect, but the square is complete. We have a full rectangle here, and we've used all the blocks, and they're in an order that seems pretty good. So now we're going to work on finding how this is factored. So this over here is what this equation looks like visually for us to see. So now from this we can find what the equation might be. So over here we have 2x squared. Oh wait, yes. Am I doing this right? We have 2x squared. Sorry, I have to copy this. Okay, so we have 2x squared over there. Let me make this all the same size. Oops. Let's do 18. Okay. And then over here, we have 1, 2, 3, 4, 5 x's. So we put 5x. This 18. Okay, you kind of see what we're doing here. And then we're going to do it. So we did it on the top, now we're going to do it on the left side. Oops, sorry, doing this the wrong way. So we have 2x squared again. And down here, we have 1x. Okay, so now this is basically our factored form. So we're just going to bring in 2x times 5. So we take 2x times 5 and then times 2x times 1. So that's basically all that our factored form is. We just took what we had here and we played around with the pieces until it fit in to make a rectangle, and then we took the dimensions of each side. So, and then using the area, we see that length times width, so this side times this side equals the area, which is this.